All right, kids, here we go with your review, 5-1 to 5-4 to 6-1. And we're going to first start right off the bat with some derivatives of integrals using fundamental theorem of calculus. And it really is not as difficult as it may seem. So all we're going to do is when we take the derivative of this guy right here, d dx, then what happens is this is our function. It gets replaced. Everywhere that you have a t becomes an x according to fundamental theorem. Don't stress out about it. Don't overthink it. Just simply replace dt with a 1. Replace that 4t with 4x. Add your plus 3. And that's it. That's all there is to it. Okay? Now, if your upper limit of integration is different, like say it's something not x, then we're going to do what's called a u substitution. We're going to let u equal x to the 1/2 power, and then we're going to say that du dx is equal to 1/2 x to the negative 1/2, okay? And then we're just going to reevaluate this integral from 0 to u of 9t well, that's an 8 there, cosine t to the 8th dt. Well, again, according to fundamental theorem, we replace the t's with u's, so this is just going to become 9u cosine u to the 8th. The dt becomes 1 or goes away, and then we just multiply by the derivative of u with respect to x. So that's this part, du dx. And once you're here, you're done, except we just replace the u's and the dx's. But we know what du dx is, and we know what u is. So this in reality is going to be 9x to the 1/2 times cosine of u, which is x to the 1/2 to the 8th, okay, x to the 4th, all right, times 1/2 x to the negative 1/2. Okay, we can clean this up a little bit. 9 times 1/2 is 9/2. X to the 1/2 times x to the negative 1/2 cancels out, and we're left with cosine of x to the 4th. So that one took a little bit of work, but it wasn't horrible. It's a u substitution. We've done this before. What about this guy right here? Question number 3. Tan x, that's going to be our u. So we're going to let u equal tan x. And then we're going to let du dx be equal to the derivative of tangent x, which is secant squared x. And so now what do we do? Now when we use our fundamental theorem of calculus, we simply rewrite this guy from 0 to u square root t dt, and we replace. That's all we do. U goes into where the square root is, square root of u, dt becomes 1, so times du dx, okay, by chain rule. And so what do? Replace the u's. We've got those u's here. We just replace them. So we're talking about the square root of tangent x times secant squared x. A prettier way to write this one would be secant squared x square root tan x. So there you go. There's fundamental theorem of calculus. Don't let this be hard. When you take derivative of all these guys, when you take the derivative of an integral, you're back to your original function. When your upper limit is a variable, that takes the place of the variable inside the function. So the x replaces the t on all of these. Don't let this be hard. Practice them a few times. See if you can work these problems out without going back and looking at how I solved them previously.